So this is technically the second video, working on number 7 here, dealing with rules of exponents. So we need to distribute the outside exponent to each and every term on the inside when there's no addition or subtraction. It's all pure multiplication. That's when we take that 2 and distribute it onto the 6, onto the 9, onto the 1 on the B. And a power to a power you multiply. So when you distribute the power of 2 on the 6, what is 6 squared? That's 36. When I distribute the power of 2, power to a power you multiply, 2 times 9 is 18. So a to the 18th. And then power to a power multiply, you end up with b to the 2nd. So that's your new numerator. And on the bottom, there's nothing to do. We're just going to rewrite it. 12b to the 13th. And now from there, you look at your numerator and your denominator, 36 over 12. You could actually reduce 36 over 12 by 12. If you reduce by 12, that'll give you a 3 up here and a 1 down there. So let me do that. You end up with a 3 up here and a 1 down there. And then you have A's up on top, but no A's on the bottom. But you do have B's on top and B's on the bottom. So you could cancel 2 of those B's up on top with 2 of these, which means you'd still have 11 down on the bottom. So my final answer to this question, number 7, would be 3 up on top, a to the 18th up on top, over 1 b to the 11th. So I'm just going to write b to the 11th. I'm not going to bother writing the 1 out in front. And that's the answer for this problem right here, number 7. Number 8. Rules of exponents. When you have the same value up on top, or the same term up on top and on the bottom, you could cancel it out. So we have C's, 9 of them up on top, 1 C on the bottom. This 1 C will cancel out with one of these, and you're going to have 8 left over up on top. And then you have 7 D's up on top and 13 D's on the bottom. So all 7 of these, that's why I put it even through the D. There's no more D's left. All 7 cancel with 7 of these, and you're going to have 6 left over up on top. I mean on the bottom. Sorry. Now, what about the 9 over 6, 9 over negative 6? First of all, we don't like seeing negative signs at the bottom, so you could put it out here right in the middle. And not only that, 9 over 6, the fraction 9 over 6, you could reduce it by 3, and you'll get 3 up here, and you'll get 2 down here. So my answer, it's looking messy, I'm sorry. There's a negative sign out in the front. There's a 3 up on top. There's a C to the 8th up on top. And on the bottom, there's a 2 and a D to the 6th. So I guess I didn't need my fraction bar that long. But anyways, there's my answer. Negative 3C to the 8th over 2D to the 6th. All right, moving on. Check out number 9. So on number 9, we have negative exponents. And we need to remember that negative exponents, you have to move them from one side to the other, making the exponent positive. So I always say circle whatever has a negative exponent and move it, right? So I want to move this one right here after the A. I want to move this b to the negative 3 and put it up here after the b to the 7th. And the c to the negative 7th, I'm also going to move it up here and put it up here at the end. So let me rewrite what I have. And let's start by writing what did not move. The 6 did not move. The 9a did not move. Now everything else did move. That a to the negative 7 up on top and moved to the bottom, and it became a to the positive 7. Oh, I forgot to put the b to the 7. That one did not move. B to the 7th did not move. This one stayed up there. So this one moved down. It became positive. This b to the negative 3, it's going to move up behind the b to the 7th and become positive. So that's going to be b to the positive 3. And also, we're going to take the c to the negative 7, move it up, and it's going to become c to the positive 7 as well. So this is our new fraction, and what we should do is simply add the exponents of the bases that are alike. So a to the 1 times a to the 7, on the bottom, you're going to have 9a to the 8th. Because a to the 1 and a to the 7, add those, you get 8. Up on top, we have the 6 that's still up there. And we also have b to the 7th times b to the 3rd. That's going to be b to the what? B to the 10th. That's right, b to the 10th. And that c to the 7th, you're going to leave it up there. Now, the only other thing you could do, or what you should do, is always check and see if you could reduce this number part, 6 over 9. If you add the fraction 6 over 9, you're able to reduce it by 3. So if you reduce by 3, you're going to have a 2 left over and a 3 on the bottom. So our final answer is 2 b to the 10th, c to the 7th, over 3 a to the 8th. Number 10, we're going to be using the rules of exponents. Rule 1, where if you have the same base, you add the exponents, or you could use that other rule that has negative exponents. You have to grab them and move them to the other side. So it's up to you if you want to add 11 plus negative 8 and put them together, or if you want to grab those negative exponents and move them to the other side. So it's totally up to you guys. I would take those negative exponents and move them down. So I want to move those guys down. All right, so what do I have up on top? I have x to the 11th, and on the bottom, I want to have the y to the positive 7, because when it moves down, it becomes positive. And this x to the negative 8 is going to move down, and it's going to become x to the positive 8. So what I have here, guys, is 11x's up on top and 8x's on the bottom. That means I could cancel 8 of them with 8 of them, right? So all 8x's on the bottom, all 8x's completely cancel out with 8 of these 11, which means that there's going to be 3 left over up on top. Therefore, my answer is x to the 3rd over y to the 7th. So number 11 looks complicated, and it's dealing with the rules of exponents, but the beauty of this question is that anything to the 0 power, and look at this whole thing is to the 0 power. That whole thing equals 1, so you could just scratch it out. I mean, technically, you could say that all of that is just a one big giant 1 right there, and there's multiplication, so you're going to multiply by 1, but what does that do? Nothing. Multiplying by 1 doesn't change anything, right? So you could just completely ignore all of this part, because to the 0 power is just going to be a 1. So this right here is really your problem right there. That's really your problem. So when you do have parentheses with an exponent on the outside, I hope you remember the rule that you must distribute that outside exponent to each term on the inside, as long as there's no addition or subtraction in there. And there isn't. So we are going to distribute 4. The power of 4 goes to the power right here on the 2. The power of 4 goes to the power on the 3. And remember the other rule, that a power to a power means that you multiply the exponents. So what you really have is 2 to the 4th, x to the 12th. Why 12th? Because a power to a power you multiply. You see how this 3 is a power and this 4 is a power? You have to multiply them. Now technically you're even multiplying right here, but there's an invisible 1 right there. There's an invisible 1 right there. So you do say 4 times 1 is 4. Anyway, that's your answer, but on your multiple choice on the midterm, they're not going to leave it like that, because we could easily do 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So your final answer on your multiple choice will be 16x to the 12th. And that's it right there, 16x to the 12th. So let's move on to the next one. Number 12, it's no longer dealing with exponents. Now we're talking about simplifying. And these are exponents that are fractions. They're called rational exponents, and we must remember that rational exponents are radicals as well. In case you forgot, let's do a little review. The power of 1/2, that's really the square root, right? The power of 1/3 is really the third root. Okay? The power of 1/4 is really the fourth root. Okay, anyways, that's just a little review right there. Let's go to question 12a. That's 125 to the power of 1/3. What kind of root is that? Is that a square root? No, it's a cube root. So what does this mean? It means that it's asking you what number times itself 3 times will give you 125. 5. So your answer is 5, and that's it. Let's try another one. Huge. This one's the power of 1/7. And I mean, there's no way I know what times itself 7 times gives me 78,000. I just don't know that off the top of my head. So I'm going to get a calculator, and I'm going to guess at it, right? I want to say like 4 to the power of 7. Because you see, ultimately, we know that the 1/7 power is the 7th root of 78,125. So what this tells me is that I'm looking for a number that I multiply with itself 7 times that'll give me 78,125. So if I go 4 to the power of 7, I'll get 16,000. That's still too low. So I'm going to go 5 to the power of 7, and I do get 78,125. So with the calculator, you just start guessing what number to the power of 7 will give you this inside value. So again, I just started guessing. 4 to the power of 7 was too low. It was 16,000 something. 5 to the power of 7 gave me 78,000. So the answer is 5 right here. Moving on. 12. There is no 12C. All right. Now these are even easier. Because, oh, there is a 12C? Oh, sorry. These ones are even easier because all you're doing is changing from exponential form to radical form, or from radical form to exponential form. So it's this simple, guys. This whole thing, 17a and b, all of it is in parentheses, right? All of it is in parentheses. So it's all to the power of 1/3. And we know that the power of 1/3 is really the 3rd root. And all of that, 17ab, all of that is inside of the 3rd root, 17ab. And that's it. You don't have to do any math. You just write it all inside of the root if it's all in parentheses. Now, if we compare that to this next one, we know that the power of 1/2 is a square root, but what has the power of 1/2? Does the 2 have the power of 1/2? Just the x, right? So just the x has the power of 1/2. That 2 out there is really just 2 out in the front, right? It says 2 times. I want to put 2 times. And then x to the power of 1/2, that's the square root of x. That's your answer. That's it. Of course, on your multiple choice, they're not going to write the times, but the multiplication. They're just going to write 2 square root of x. And that is your answer. Again, those parentheses make a difference. If you have parentheses around it, then the whole thing is going to be inside your root. If there are no parentheses around the whole thing, then only the thing that has the exponent is going to be inside the root. That number goes out here in the front. Continuing on here, let's jump to the backside. On the backside, you have some solving equations, and they're pretty simple. They look complicated. If you don't know what you're doing, they will be complicated, but it's this simple, guys. Whatever base you have here, because your x is an exponent, you would like the same exact base right here. So what you would like to do with the calculator is change this huge number to 9 to a certain power, right? So this 9 to the x, I'm going to leave it 9 to the x. But then I have equals, and instead of 729, I'm going to figure out what 9 to the power of something will give me 729. So on my calculator, I start guessing. 9 to the power of 4. Nope. Too big. 9 to the power of 3. Yep. 729. So in this situation, my 729 could be rewritten as 9 to the power of 3. And now that we have the same base, I hope we remember that you could just eliminate those bases and the exponents come down and create a new simple equation. So the 9s disappear and your new simple equation is x equals 3. Now sometimes you have to solve it, but if you just have the answer already, you're done. But if you would have had like a 2x plus 1 equals 3, then you'd have to solve that equation. Number 16, on my example here, I have 11 to the power of 2x minus 1, and then I have 1,331. I don't want that huge number. I would like the same base. I have an 11 here. I would like an 11 over here. So I have 11 to the 2x minus 1 equals 11 to the, let's find out what it is on the calculator, 11 to the, I don't know, 3rd power. Let's try. That's exactly right. got lucky, guessed on the first one. 11 to the third power is 1,331. So because now we have the same bases, we could just eliminate those bases, scratch them out. Your new equation becomes 2x minus 1 equals 3. And now you could solve it by adding 1, adding 1. You're going to get 2x equals 4. Then you could divide by 2 on both sides, and you get x equals 2. And that is your answer for this one. Moving on. Number 17, graphing. Now remember, on the midterm itself, you're not going to actually graph. You're going to have 4 multiple choices that already have graphs on them. So it says, graph the exponential function y equals 2 to the x minus 4. I hope we remember that step 1 on graphing an exponential function is to ignore h and k. Ignore h and k. So we're going to look at the equation y equals 2 to the x. We're going to make an xy table for it. And then at the end of it all, once we graph it, we're going to shift it down 4 units because the asymptote is at y equals negative 4. This k value tells you we're going to shift the whole graph down 4 units. So let's begin by doing consecutive integer inputs, negative 3, negative 2, negative 1, 0, 1, 2, 3. Let's plug in the easiest number, 0. 0 right here would give you 2 to the 0, which gives you the output of 1. And then you could continue to plug in the other inputs, or you could use your growth factor, which is 2, and make that output grow by 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. And if you're multiplying by 2 this way, backwards is dividing by 2. Or as I'd like to say, if you're multiplying by 2 this way, backwards is multiplying by the reciprocal of 2, which is multiplying by half. 8 times half is 4, 4 times half is 2, 2 times half is 1, 1 times half is 1 half, 1/4, 1/8. So I have my parent graph coordinates. Let me graph them. 0, 1 is right here. 1, 2 is right here. 2, 4 is right here. 3, 8 is off my graph. If I wanted to, I could put it somewhere up here, right? And then going to the left, negative 1 and half is right there. Negative 2 and 1/4 is right there. Negative 3 and 1/8 is right there. 16th, 1/32. That's your parent graph. You still need to shift it 4 units down. So take each one of those points and move them 4 units down. This one, 1, 2, 3, 4. You end up right here. The next one, 1, 2, 3, 4. You end up right here. And so on and so on. And the asymptote itself, check it out. The asymptote on the parent graph used to be up here. Shift it 4 units down. 1, 2, 3, 4. Here's your new asymptote. So if you just connect your dots, you'll have your final graph. And of course, you're going to have 4 graphs already. And then it says state all that you can. State the y-intercept. Well, where does it cross the y-axis? In this case, it crosses the y right here at 0, negative 3. 0, negative 3. What else? They want the domain and range. The domain, that's x equals what? Everybody should know x equals all real numbers. For the range, we're talking about the y values, and that's either going to be above or below your asymptote value. And your asymptote value is the line that your graph infinitely approaches. You could also call your asymptote, or you could locate your asymptote by saying y equals k. And your k is the negative 4. So y equals negative 4 is your asymptote. But anyways, this graph, is it above the y equals negative 4 or below the y equals negative 4? It's above. This whole graph is above this level. It's not below this level. It's above the level of y equals negative 4. So how do we say that in terms of an inequality? Y is above negative 4. It's greater than negative 4. Okay, so I do want to mention that if you happen to have drawn your parent graph, then that's not your answer. Your answer is this red one, right? So if you happen to draw this one, that's okay. Just make sure you put 2 X's on it so I know that that's not the correct graph. The one that you shifted down 4 units is the correct graph. All right, let's try this next one. It's also exponential function, but in this case we have a decay function. Remember, if the base is greater than 1, it's a growth. If the base is less than 1, it's a decay. And the a value of -1 means that it reflects over the x-axis. So just like before, we're going to ignore h and k. So the first thing to do would be focusing on this parent graph with the a value of -1 and make an xy table for it. Use consecutive integer inputs. Plug in an easy number like 0. 0 right here would give you a 1, but with the negative in front, that'll be -1. So we're going to have a -1 as the output for the input 0. Now the next output would simply be decreasing by this decay factor of 1/2. Because we have consecutive integer inputs, I could take this one and decrease it by half. So it's still negative, it's going to decrease to -1/2. And then decrease it by half again. In other words, multiply it by 1/2. That's going to give you 1/4. And of course, we're talking about -1/4. And then multiply it by half again, -1/8. And then the next one, -1/16. And then -1/32, 1/64. And it keeps getting smaller and smaller forever, infinitely approaching 0. So if you're multiplying by half this way, backwards would be dividing by half, which is really multiplying by the reciprocal of half, which is really multiplying by 2. Because if I say -1/2 times 2, that'll give you a -1. -1 times 2, that'll give you a -2. -2 times 2 is -4. -4 times 2 is -8. You have all the coordinates of your parent graph. Let's start with 0, -1. That means 0 on the x, -1 on the y. So you put your first dot right there, 0, -1. And then we're going to go to 1, -1/2. So if you go 1 on the x, and then not even halfway down, not even to the -1, but only halfway down, that'll get you that next coordinate. And then the next one is 2, -4, -1/4. So if you go 2 on the x, -4 of the way down, that's only half of the half. So it's even closer to 0. And then the next one, 3 and -1/8, it's even closer. 4 and -1/16. 5 and -1/32. It's so close, that it looks like I'm drawing dots on the line itself. And I know it's infinitely approaching. You could draw some dots on the line, even though you know it never actually touches, just infinitely approaches. Let's go to the negative direction, -1 and -1 and -2. So -1 and -2, let's put a dot right there. Let's go to -2 and -4, that's down here. Let's go to -3 and -8, that's down here. This is your parent graph. All you need to do is shift it according to your k value, +6. So this asymptote that used to be at y = 0 is now going to be at y = 6. 1, 2, 3, 4, 5, 6 right here. And you got to take all these coordinates. This one that was at the 0, -1, move it 6 units up. 1, 2, 3, 4, 5. 6. Sorry. 1, 2, 3, 4, 5, 6. And then move the other one 6 units up. So move this one 6 units up. And this one 6 units up. And this one 6 units up. And of course the halfway one, this one right here, is going to go halfway to your asymptote, but you already know it's infinitely approaching, so you could just fill it in. By the way, on the test itself, these graphs are already going to be done for you, so it'll be way easier. Put an arrow on it. If you did graph that blue one, put 2 X's on it so I don't make the mistake of grading that one. So once again, easy points. The domain of any exponential growth or decay function is x equals all real numbers. The range is the y values that are above or below your asymptote. In case you forgot your asymptote, your asymptote is y equals k, but in this case y equals 6 because your k value is 6. And that makes total sense because this graph infinitely approaches the y equals 6 line. That's your asymptote. So your range is either, your graph is either above or below this asymptote. What do you guys say, above or below? Below. So y is less than 6. The only other thing you could state is your y-intercept. That would be the location 0, 5. 0, 5 is your y-intercept. And that's about it.